Cloud engineering can pay around $135,000 per year in the United States. That is the number most people see, and it is the number that attracts attention. But it is not the number most people experience when they enter the field. Entry-level roles often begin closer to $85,000, and many candidates never secure that first offer. Here is the hard truth. Cloud engineering is no longer a fast entry into high-income technology. The easy window closed. During the aggressive migration years, companies were moving infrastructure at speed. They hired quickly, tolerated knowledge gaps, and valued momentum over precision. That hiring environment created unusually fast salary growth. That phase has matured. Cloud is now standard infrastructure, and standard infrastructure demands competence, not potential. Mid-level engineers typically earn around $135,000. Senior engineers can reach $185,000 or more depending on scale and responsibility. The upside remains real, but the path has narrowed. Salary structure reveals how the field actually functions. At entry level, responsibility is limited. You are not designing global architectures. You are maintaining systems already built. You monitor alerts, troubleshoot deployments, write incremental automation, and learn how production systems behave under pressure. It is operational work, not visionary engineering. This stage builds familiarity with real constraints and exposes you to the realities of production environments where mistakes carry consequences. Mid-level engineers move into ownership. You begin designing scalable systems, managing infrastructure as code properly, evaluating redundancy strategies, calculating cost impact, and reducing inefficiencies. You integrate security into design rather than reacting to it later. Compensation accelerates because ownership creates leverage. Senior engineers operate differently. They think in regions, not servers. They design disaster recovery strategies, evaluate performance trade-offs, influence architectural direction, and manage cost governance at scale. That level of responsibility supports compensation above $180,000 because it directly affects business outcomes and organizational risk. But salary alone does not determine whether cloud engineering is worth it. Market demand determines stability. Cloud demand remains real. Organizations are deeply invested in AWS, Azure, and Google Cloud. Infrastructure migrations are expensive and complex, which makes reversal unlikely. However, growth has shifted. Expansion projects have slowed. Optimization projects dominate. Companies are asking how to reduce cloud spending, improve reliability, and strengthen security, rather than how to migrate faster. This shift changes hiring behavior. They hire more precisely. They look for engineers who understand cost deeply, prevent outages, and optimize architecture, instead of simply deploying templates or repeating tutorial patterns. Competition reflects that maturity. Certifications are common. Boot camps produce large volumes of candidates. Online resources make technical knowledge accessible globally. The barrier is no longer information. The barrier is demonstrated execution. Hiring managers evaluate real deployments, real scaling problems, and real automation beyond tutorials. They ask about failures, outages, trade-offs, and cost incidents. They want evidence of production exposure, where decisions had measurable consequences. Junior reality often feels different from expectations. Breaking in may require persistence. The first role may involve maintenance tasks, monitoring responsibilities, incremental improvements, and support rotations rather than large-scale architecture. Progression takes demonstrated competence and reliability over time, but cloud skills compound. Automation exposure leads to DevOps capability. DevOps capability leads to reliability engineering. Reliability engineering leads to architectural ownership. Architectural ownership increases strategic influence. Strategic influence increases compensation, because you are no longer executing tasks but shaping infrastructure direction. Long-term outlook requires realism. Cloud engineering is no longer explosive growth. It is foundational infrastructure. Foundational systems move slower, but they persist. As long as distributed applications exist, cloud expertise remains relevant. The opportunity still exists, but it rewards depth rather than surface-level engagement. Superficial skill sets feel crowded. Deep competence remains scarce, and therefore more valuable. There is another question most people avoid asking. Who should not pursue cloud engineering in 2026? If you are looking for rapid income with minimal depth, cloud will frustrate you. If you prefer constant novelty over system stability, cloud may feel repetitive. Infrastructure work requires patience, precision, and tolerance for incremental improvement. If you are motivated purely by salary headlines, the early stages may feel underwhelming. Entry-level roles demand reliability before creativity and discipline before influence. Cloud engineering rewards those who enjoy systems thinking, those comfortable working behind the scenes, and those who can analyze trade-offs calmly over long horizons. If you prefer highly visible product impact or constant experimentation, other fields may align better. Cloud is less about building something flashy and more about ensuring everything else keeps running. That distinction matters more than compensation projections. Another factor rarely discussed is strategic positioning within the cloud ecosystem. Not all cloud engineers operate at the same leverage point. Some remain focused on deployment scripts and configuration management for years. Others move toward architectural abstraction, governance, identity management, security boundaries, and large-scale cost strategy. The difference between those paths is not only salary, it is control. Engineers who understand multi-account structures, compliance requirements, and cost allocation models influence decisions that affect millions in infrastructure spend. That level of responsibility changes compensation conversations entirely. There is also a regional and structural dimension. Compensation varies significantly depending on geography, remote flexibility, and company scale. Engineers who position themselves for distributed teams and global infrastructure environments often access higher salary bands. Those limited to small-scale deployments may cap their growth earlier. The cloud market increasingly rewards adaptability across platforms rather than loyalty to a single vendor. Multi-cloud literacy and cross-platform fluency become differentiators over time. Resilience is another overlooked variable. Cloud outages happen, security incidents happen, budget overruns happen. Engineers who respond calmly under pressure build reputational capital. That capital compounds faster than certifications. Over time, reputation becomes a silent salary multiplier. Organizations trust engineers who have handled real incidents responsibly. That trust converts into leadership roles, architectural authority, and compensation leverage that extends beyond base salary numbers. So is cloud engineering still worth it in 2026? Yes, but only if you approach it as a long-term discipline. Certifications alone will not differentiate you. Surface-level familiarity will not protect you from competition. If you build real deployment experience, understand cost structures, integrate security, think architecturally, and develop resilience under pressure, the financial upside remains justified. Cloud engineering is not hype anymore, it is infrastructure, and infrastructure rewards seriousness.